Hi folks, Will right here. I want to make a quick video demonstrating a topic that comes out of eMathInstruction Algebra 1, Unit 7, which is about polynomials. There's an optional topic called multiplying polynomials using area models. And I want to walk through that. There's no video lesson out there, but I want to make this in case you need it. This is what it looks like. And this takes the idea of multiplication in the area of a rectangle. We all know the basics of an area of a rectangle. You've been doing this forever, right? If you have a rectangle that's 2 by 3, we know to get the area, you just multiply and get 6. Well, imagine here I am on the page. I hope you have this printed in front of you, but we're gonna try to find the area of this rectangle. It's 12 feet by 23 feet. Now, I don't know exactly what 12 times 23 is, but I know how to do it. It's 23 times 12. So remember, I take the 2 and I multiply by 3 and I get 6. And 2 times 2 is 4. Then I'm going to multiply the 1. Now, really, remember, this is a 2. This 1 is in the tens place. That has the value of a 10. So really what I'm doing is I'm multiplying 10 times 23. I need to put a placeholder here. Some people do this, some people don't, but I'm going to do it. 1 times 3 is 3. And 1 times 2 is 2. And then what do? I add those together. That's a 6. That's a 7. That's a 2. So the area of this thing must be 276. And since they gave me units, I'll put units on my answer too. That is feet squared. Okay, well, like I mentioned, 23 is really 20 and 3, and 12 is really 10 and 2. I could break that rectangle up into 4 smaller rectangles like this. And so the 23 became 20 and 3, and the 12 became 10 and 2. I'm going to find the area of each of these 4 smaller rectangles. The math is much easier. 10 times 20, of course, is 200. You know, that yellow doesn't show up very well. Let me try a different color on that. 10 and 20 we said was, that's really not showing up. Let's just try green. This is 200. Sorry about that. 10 times 3. So this rectangle over here has the dimensions of 10 times 3, which we know is 30 square feet. This one is 2. This length is 20. I can tell because that's the length at the top. 2 times 20 is 40. 2 times 3 is 6. Notice here that these on this diagonal are both tens. This is my hundreds place. These two things are my tens place, and that's my ones place. So when I go ahead and I write this out now, it's really 200 plus 40 plus 30 plus 6. With these things being my tens, I can combine that. But when I add this up now, I get 276. Notice it matches the 276 we got up there. Okay, well, we talked earlier about how polynomials and numbers have a lot of similarities. So here I am, 2x plus 3 and x plus 2. You can almost imagine that that's 23 and that's 12. And I could do the same thing. I'm going to do long division with polynomials here. My process is going to be the same. I'm going to take the 2 and I'm going to multiply it by both things. 2 times 3 is 6. 2 times 2x is 4x. I'll put a plus in the middle just so we don't get confused. X times 3 is 3x. I'm going to write that 3x under the 4x to make it easier to add in a minute. X times 2x is 2x squared. I'll write that over here to the left so that it's in decreasing order of degree. Let's add those together. I have only one thing, which is the 2x squared. I have one thing that's got a single x, or two things, which is those add to 7x, and I've got a 6. So the area of this thing, this big rectangle, is 2x squared plus 7x plus 6, which is really similar, by the way, to the 276 we got up there, isn't it? 276 broke down to that. Okay, let's take this to the next step. The same way the same way that we combined, or that we broke 23 and 12 into 20 and 3 and 10 and 2, I can do the same thing here. I'm going to take that 2x plus 3, but I'm going to break it. This is 2x, and this length is 3. This length is x, and this length is 2. So I'm trying to find the area of this biggest rectangle in the top left. The dimensions are x and 2x. What is x times 2x? We all know that that is 2x squared. The area of this rectangle is 3, and the height is x. That's coming right off of there, right? That height matches, that's x. 3 times x is 3x. This 2x and this 2. So this is a 2x by 2 rectangle, which is 4x. In this thing over here, this is length of 2, this is 3. We know 2 times 3 is 6. Okay, notice that on my diagonal, those are both x's. When I go to combine this, I have a 2x squared. I have 4x and 3x, that makes 7x. And then I've got this last remaining thing, the constant, which is 6. That was a long process to show you how this works. Let's try one without all those intermediate steps. Let's just take a look at this. If I have, I'm multiplying this, notice that this is a binomial. As a matter of fact, they're both binomials, right? That's a binomial, and that's a binomial. I'm multiplying two binomials. I'm going to split it up. 4x plus 7, I'm going to put that at the top. There's my 4x. There's my 7. 3x plus 2, I've got a 3x, and I've got a 2. And now I'm going to find the area of each of these. 4x times 3x is 12x squared. 7 times 3x is 21x. 4x times 2 is 8x. 7 times 2 is 14. I still have along my diagonal right here, those are my x terms. So when I figure all this out, I have a 12x squared. I have 21x and 8x. We know that combines to 29x. The x stays the same. I add the coefficients. 21 and plus 8 is 29. And I have a 14. That's my answer. This right here is my answer. This is what we started with. It was two binomials multiplied together. That became this. These are actually linear binomials, and we're going to see this a lot. Two linear binomials multiplied became one quadratic trinomial. To go back to using some of our vocabulary. Okay, let's try some other ones on the next page. X plus 8, x plus 2. I don't really care. It doesn't matter where you put them. I could do x plus 8 at the top, or I could do it on the left, as long as I have one of them one place and one of them the other. I know I've seen a lot of people do the x plus 8 on the left and the x plus 2 up here. It doesn't matter. But you go through and you do the quick multiplications. And then you combine like terms and you rewrite it. X squared plus 10x plus 16. Remember that 10x came out of this diagonal. Those are like terms, so I combine them. What about this one? 5x plus 4. 5x plus 4. And 3x minus 2. This is our first one with a negative. This is a 3x minus 2. I don't usually write the plus here. I guess I could, but there's no reason to. So I don't typically write that plus up there. I'm just going to put the 5x. So the only time I would write the sign is if it's negative. And that makes a difference. It makes it a little bit more complicated, not bad. This is a little harder too. 3x times 5x. What do? 3 times 5 is 15. X times x is x squared. Let's work on this box. 4 times 3x is 12x. 5x times negative 2 is negative 10x. 4 times negative 2 is negative 8. Okay, and again, on the diagonal, those are like terms. Those are the linear terms. What have I got? 15x squared plus 2x minus 8. The 2x came from these two things, 12x and negative 10x combined to 2x. Awesome. I turned two linear binomials, I multiplied them, and I got one quadratic trinomial. I told you we're going to see it again and again. Why don't you try C? Go ahead and pause the video for a second and try C. I'll do it. I'll give it about 10 seconds and I'll do it. Go ahead and pause. Okay, I'm hoping you paused and you did this. I'm going to put 2x minus 7, 8x minus 5. And let's do the multiplication. 16x squared minus 56x minus 10x plus 35. A negative times a negative is a positive. Oh, these numbers are bigger, but they're not bad. 16x squared. Along this diagonal, 10 is easy to combine with. That's negative 66x plus 35. That was definitely harder. Now on these, I want to use the area model because that's what we're practicing, but it's not drawn for me. So I'm going to have to draw it. So I'm going to draw a quick area model, just a 2x2 grid. And we'll put some things on top. I've got a 3x minus 7 and an x plus 5. Oops, I wrote the plus, doesn't matter. This becomes 3x squared minus 7x, 15x, and negative 35. I'm not talking through the details here, but all I'm doing is I'm multiplying the length times the width to find those four areas. Now let's combine things. Notice the diagonal is like terms. It always should be like terms. If it's not, you made a mistake. 3x squared, let's see, 15 minus 7 is 8. So that's 8x minus 35. I hope you're getting the hang of this. Why don't you pause and then come back and check your answers to these? So go ahead and hit the pause button. Do E and F. Actually, do E, and then unpause. Okay, I'm hoping you got E done. Let's try it again. I'm going to draw the grid. Make it a little bit bigger than I did last time. I'm going to just to switch things up. I'm going to put. I don't want to use black. That was the color of my grid. Let's pick red again. I'll put my first term along the left this time, just to show you that it's possible. Oh, let's see. 10x times 4x, that's 40x squared. 7 times 10x is 70x. 4x times 3 is 12x, and 3 times 7 is 21. Then all I've got to do is rewrite it. I have a 40x squared. That never changes. The inners, 70 and 12, that's 82. That's easy math. Plus 21. All right, I have an answer. Okay, look at this final one. It's quite a bit harder. It's quite a bit harder. What you have to realize, the square tells me that what this really is 5x plus 2 times itself. 5x plus 2 times 5x plus 2. So when I set this up in my multiplication grid, I'm going to have 5x plus 2 and 5x plus 2. 25x squared, 10x. These are going to match. If I have something that's squared, the things on the diagonal will always match. 25x squared plus 20x plus 4. Done. Okay, so this one was a little bit harder because it was squared. The next one's even more interesting. This is a binomial times a trinomial, right? This is a linear binomial times a quadratic trinomial. The process is the same. The 3x plus 5 ended up here. These three terms ended up across the top. And again, you could have made it instead of a 2 by 3. You could have. Oh, I hit the wrong button. I don't want to erase everything. You could have made it tall and skinny instead of short and wide, but the math is going to be the same. So 2x squared is here, negative 7x is here, 4 is here. Let's figure this out. 3x times 2. Well, 3 times 2 is 6. We haven't done a whole lot of this, but x times x squared is x to the third, which you could say is x cubed. Okay. Negative 7x and 3x. Well, 3 times negative 7 is negative 21, and x times x we know is x squared. This one is 4 times 3x, that's 12x. 2x squared times 5 is 10x squared. Negative 7 times 5, that's negative 35, and there's an x on it. Then 4 times 5 is 20. Okay, remember we talked all that time about diagonals. Well, check this out. There's one diagonal here that's x squared. There's another diagonal here that's x. So now we've got two diagonals. Well, let's rewrite this. I've got a 6x cubed. Well, what do I have that's squared? There are two of them that are squared. It's a 10x and a negative 21x squared. 10x squared, negative 21x squared combines to negative 11x squared. Then I have a negative 35x and a 12. Let's say it'd be 35, 25, 23. Negative 23x plus 20. Perfect. So this notice, by the way, when I multiply by a linear binomial, this was second degree. My answer down here is third degree, so it became a cubic rather than a quadratic. And it also went from 3 terms to 4 terms. That's pretty common with these. There's only one left to do. You can pause and try it on your own and then come back, and we'll see if our answers match. Okay, I'm going to go ahead and start this. It has to be a really wide box because it's going to have 3 columns in it. And I'm going to put a 4x squared and a minus 5x and a minus 1 and an 8x and a negative 3. Lots of negatives. We got to pay careful attention. I'm gonna go right through this without wasting too much time. But if you have any questions, you can always pause and take a more detailed look at what I'm doing. I'm just going to go through this fairly quickly. There, I did all those multiplications. I found the area of all 6 little tiny boxes. The negatives were indeed a challenge. Now, again, my diagonals, right? Here, this diagonal is my quadratic term. This diagonal is my linear term. Let's see what we end up with. 32x to the third. This is minus a negative 40 and 12. 40 and 12 make 52. Negative 52x squared. 15 minus 8 is 7. And 3. That's my answer. Hey, hope you found this helpful. I hope you're able to look at this and make some sense of how the area model can help you multiply polynomials. This is one of several techniques. Many people find this one helpful. We'll talk more later. Bye for now.